All right, let's just jump straight in. Welcome to this explainer. Today, we're unpacking the pure, unadulterated biomechanics of human acceleration. You know when you're watching a short-distance sprint and you just marvel at that sheer explosive power right off the starting line? Well, it looks like raw talent, but beneath that explosion is a highly calculated mechanical sequence. We're going to break down the actual anatomy of speed today, specifically focusing on how mastering the crouch start builds that ultimate acceleration.
So you really have to ask yourself, how exactly do these athletes go from absolute zero to their absolute top speed in just milliseconds? When we're talking about any race under 400 meters, we really have to frame the start as a physics problem. In these short distances, the whole outcome is overwhelmingly decided by just two things: an incredibly fast initial reaction time to the gun and the athlete's maximum acceleration capacity right out of the gate.
To solve this physics problem, athletes use what's known as a crouch start, or sometimes you'll hear it called a sitting start. Now, if you watch middle or long-distance runners, they use a standing start, right? Because they need smooth pacing over a longer time. But the crouch start, it is fundamentally different. It's specifically engineered to manipulate the body's center of gravity. By lowering the body and positioning it just perfectly in that set position, the runner is primed for immediate explosive speed. It's literally all about manufacturing forward momentum from a dead stop.
Okay, let's break this down. Phase 1. On your marks. Let's slow things right down here to mirror the mounting tension of a real race. Take a close look at this careful, deliberate posture. This is the foundation for everything. The runner is positioned directly in front of the blocks. The foot of their stronger leg is placed squarely on the front block, while the other foot goes on the rear block. Notice how that rear foot is pressed firmly backward, and the knee of that rear leg is just resting calmly on the ground. And actually, look closely, only the very tip of the front foot is even touching the track. It's this incredible position of quiet readiness.
Building on that setup, let's look at the granular upper body adjustments. The hands aren't just slapped flat on the ground. They're placed exactly shoulder-width apart, and the thumbs and index fingers are spread to form a high bridge. Why do they do that? Well, it gives them immediate clearance and support. Also, look at the head. It has to be completely relaxed, eyes focused straight down on the ground. If an athlete tenses their neck or shoulders here by looking up, boom, they're already bleeding potential speed before the gun even goes off.
Next up, Phase 2. Set. So, the stadium is totally silent. The tension is peaking. On that set command, the runner raises their hips by lifting that rear knee right off the ground. Suddenly, their body weight isn't resting passively anymore. It's distributed almost evenly across 4 supporting areas, the 2 hands forming those high bridges and the 2 feet pressed hard against the blocks. And importantly, that head stays in that natural, relaxed, downward-facing position.
Now here is the absolutely crucial part, the geometry happening in the legs. To get the highest possible initial speed, we are looking for some incredibly specific angles. The front knee needs to be at an angle of exactly about 90 degrees. The rear knee, it needs to be a bit more open, sitting perfectly between 110 and 130 degrees. These aren't just random numbers a coach made up. These are the precise mechanical angles required to optimize explosive pushing force.
By hitting those exact angles and distributing their weight just right, the runner essentially turns their entire body into a tightly coiled spring. This set position conveys preliminary tension to the body. The runner is loaded with intense potential energy, locked in, holding their breath, just waiting for that singular signal to release all that stored power straight into the track.
And then Phase 3, go, the drive phase. Go. The gun rings out and there can be zero delay here. A rapid response is absolutely paramount. Look at the explosive pushing action happening. Both legs are driving so aggressively against the starting blocks. The physics at play mean that the immense power exerted backward onto the blocks transmits the highest possible initial forward velocity to the runner's body. They aren't just standing up and running. They are literally launching themselves horizontally, kind of like a projectile.
It's really a simultaneous symphony of biomechanical movements. After coming off the rear block, that push-off leg immediately drives forward and upward, while the leading leg stays almost perfectly horizontal. But hey, don't forget the arms. To produce this acceleration, the arms have to swing rapidly. The forward arm bends at the elbow to about 90 degrees in its final phase, with a slight outward spread, while the opposite arm performs this vicious backward counter-movement. That arm pump is vital. It balances the immense torque being generated by those driving legs.
Moving right along to Phase 4, the acceleration phase.
So they're out of the blocks and immediately into acceleration. The race is on, but the runner hasn't hit top speed yet. This crucial window is where races are won or lost, before they're even halfway over. The defining characteristic here is a marked forward body lean. You want the angle between the runner's body and the ground to be as small as physically possible during those initial strides. As the stride rate and length increase, this sharp inclination gradually decreases. It takes about 20 meters for the runner to finally unfold into a normal, upright sprinting position.
The difference between a powerful block exit and a poor one is pretty wild to see. A powerful exit naturally creates and maintains that essential forward lean because the force is pushing you forward, not upward. On the flip side, runners with a poor push-off force will find themselves popping upright way too soon. And sometimes, even with a great push-off, a runner will totally ruin their acceleration just by raising their head to look at the finish line prematurely. That slight upward head movement forces the body upright and instantly kills their acceleration curve. Tragic, really.
Putting it all together, just watch the evolution from left to right. You can see the tightly coiled set position, the explosive double leg push in the drive phase, and then that aggressive forward lean in the acceleration phase. Notice how the body gradually unfolds over those first 20 meters. It's a seamless, fluid transition from maximum forward lean to a full upright sprinting stride. It's honestly a masterpiece of kinetic energy transfer.
Finally, Phase 5, the finish line.
Okay, we've reached the climax of the sprint. The acceleration phase is long over, and now it's all about holding on to that top speed right through the tape. But at the very last fraction of a second, we see the shoulder shrug technique. Instead of just running straight through the line, a smart runner leans forward slightly, aggressively throwing one shoulder forward exactly at the finish line. Because crossing the line is determined by the torso, not the head or the arms, this tiny sudden rotation can steal an advantage in a razor-thin photo finish race. A real game changer.
So, we've broken down exactly how perfect crouch starts build ultimate acceleration, and it leaves us with this really fascinating thought. If mere milliseconds of speed are born from exact degrees of knee flexion, a high finger bridge, and the precise angle of a forward lean, how else can we manipulate human anatomy and physics to outrun the clock? The human body is the ultimate machine, and the track is really just a laboratory for testing its limits. Thanks so much for joining me on this explainer. Keep wondering and keep learning.